All right, let's get right into it. Today, we're diving into the single biggest shift in vehicle safety since the invention of the airbag. And I want to be clear, this isn't just some small evolution. We are talking about a full-blown revolution in how we think about, how we design, and how we validate safety. If you're an automotive engineer, this is the strategic briefing you absolutely cannot afford to miss.
Okay, so let's cut right to the chase with the main conclusion, right up front. The era where active and passive safety systems lived in their own separate worlds, well, that's over. The future, which, let's be honest, is already here, is all about a fused, intelligent ecosystem where the car actually predicts and prepares for a collision long before it happens. This one idea is the key to everything else we're about to cover.
And look at this. This slide completely rewrites what we even mean by a crash event. For years, we've been obsessed with the moment of impact, right? T0. But now safety is a continuous timeline. It starts seconds before a potential crash with prediction and prevention. It adapts in real time during the crash, and it extends into the crucial moments after the crash with response and rescue. This right here, this is the new mental model for vehicle safety.
So you might be asking, what's driving this huge shift? Well, the main catalyst is a regulatory earthquake, and the epicenter is Euro NCAP. The changes that are coming down the pike aren't just small tweaks. They're fundamental, and they make this new integrated approach an absolute must-have if you want to get a 5-star rating.
Euro NCAP is ditching its old system for this new 4-box structure, and you can see how it perfectly mirrors that safety timeline we just talked about. Each of these pillars is weighted equally. But here's the kicker. Being great in one area isn't good enough anymore. To get a 5-star rating, a vehicle has to score at least 80% in every single one of these boxes. If you're weak in just one, the whole system fails.
And this number just brilliantly illustrates the insane scale of the engineering challenge we're facing. I mean, think about it. A decade ago, we were dealing with what, fewer than 50 test scenarios? By 2026, it's going to be over 1,200. That explosion in complexity makes doing exhaustive physical testing completely impossible. It demands a whole new way of thinking about validation.
Okay, so how in the world do you respond to that kind of complexity? Well, the engineering response has to be just as integrated as the problem itself. And that brings us to the idea of technology fusion.
The answer is IPAS, Integrated, Passive, and Active Safety. Now, this isn't just another acronym or a new feature you can add. It's a fundamental design philosophy. It's really about connecting the car's senses, its eyes and ears, the cameras and radars, directly to its muscles, the seatbelts and airbags, and doing it all in those critical moments before an impact ever happens.
But for IPAS to actually work, the car's entire nervous system needs a radical upgrade. The old way of doing things, with dozens of separate controllers that barely talk to each other, is just way too slow. The new paradigm is a centralized, brain-like system. You have a high-performance computer making the big decisions, talking to zonal gateways over a super-fast data backbone. Honestly, this is the only way you can get the millisecond-level communication that predictive safety needs.
So let's make this real for a second. In the 200 milliseconds before a predicted impact, and that's literally the blink of an eye, this is what iPace is doing. First, active seatbelts gently pull you into the perfect seating position. Then, based on in-cabin sensors that know your size and posture, the system decides on the ideal airbag strategy just for you. So by the time the impact happens at T0, the passive systems are running a custom-tailored protection plan, not just a one-size-fits-all reaction.
We've covered the new regulations, and we've covered the technology to meet them. But that leaves one huge, critical question. With systems this complex and predictive, how on earth do you actually test and certify them? Especially with over 1,200 scenarios to cover?
Well, the first part of the answer is that we have to move beyond plastic and steel. We're shifting away from the classic crash test dummy and towards human body models. These are incredibly detailed digital twins of the human body. They let engineers simulate injury risk for a huge range of body types, ages, and seating positions, stuff that's just physically impossible to do with a few very expensive physical dummies.
And this move to digital brings us to virtual testing, which is now a formal part of the approval process, also known as homologation. This is a real game changer. Simulation is no longer just some internal R&D tool, it's now official evidence that you submit to regulators. And really, it's the only way you can possibly prove performance across thousands of different test cases.
Now you might be thinking, great, so physical tests are going away. But that's not it at all. Virtual testing doesn't eliminate physical tests. In fact, it makes them even more important.
The few physical tests we still do are used to prove that the virtual models are accurate. And these tests are more complex than ever, demanding a level of precision we've just never seen before. And that's where this incredible advanced hardware becomes absolutely critical. To reproduce these complex scenarios perfectly, time after time, you need specialized gear. We're talking about things like ultra-low platforms that don't mess with the car's radar, driving robots that can follow a path with millimeter-perfect accuracy, and durable soft targets that look totally real to the car's sensors. Companies like AB Dynamics are building the tools that are making this whole new era of high-precision physical testing possible.
So, let's pull all of these threads together. What does this all mean in practice? What are the clear, actionable priorities for engineering leaders who are trying to navigate this new software-defined world of safety?
Okay, here are the key takeaways. First, architecture is everything. Without that centralized zonal E/E architecture, I-PACE is a non-starter. Second, you have to invest heavily in your virtual toolchain. Simulation isn't a nice-to-have anymore, it's a core competency. Third, master raw data fusion. This is how you build a more robust perception system. And finally, and this might be the hardest one, you have to fuse your organization. The old silos between active safety, passive safety, and cybersecurity, they have to come down. The bottom line is this: the battle for vehicle safety is no longer won in the crash lab. It's one in the architecture, it's one in the code, and it's one in the simulation.
And that leaves us to our final question. This is a strategic challenge that every single automaker and engineering team needs to think about. In this new era, where a car's ability to protect people is defined more by its predictive software than its physical steel, what business are you really in? Is your core competency still bending metal, or is it writing the algorithms that make bending metal a last resort?